Hi, I'm Arda, and I will present you measurement techniques for the wear analysis of some car components. Estimating wear rates of materials is essential for design, development, and maintenance purposes. Tires and brake elements are two of the car components that are consumed most and needs frequent replacement. So I include the methods used for their wear measurements. Also, a modern state-of-the-art technique is used for measuring wear rates of internal combustion engine components. I will mention the advantages of this technique and why it is a superior one. Firstly, I will introduce briefly the test setups utilized for generating wear on these elements. And I will continue with the methods utilized to measure wear rate of these components. Pin-on-disc and ball-on-disc methods are the most common versatile techniques in the wear test of materials. Many materials in the industry can be analyzed with these methods when the samples are produced in the suitable geometric forms. In the scope of this review, they are used for testing brake elements. Pin-on-disc setup is comprised of a revolving disc and the pin in contact with it, where a line contact is established. In ball and disc method, the material in the form of a sphere is rolling and the stationary disc is in contact with it. This time, a point contact is established. Inertia test bed is another setup for the analysis of brake materials. This setup represents the actual contact between a friction pair better. Although the accuracy is better, since it is more costly, this setup is used less frequently than the previous methods. When it comes to the test of the tires, a circular tire track can be employed. The pavement of the track represents the road the tires are in contact. This pavement can be changed to observe the effects of roads with different characteristics. The tires are rotated by driving the wheels with electric motors. Also, the temperature of the track can be changed to see its effects on the behavior of the friction pair. Now, let's move on to wear measurement techniques. The first method I will discuss is gravimetric method. This method simply compares the mass of the component whose wear rate is measured before and after the application of wear. The simplicity and versatility of this method makes it the most commonly employed measurement technique. However, one drawback of this method is that it does not allow continuous, or it is named as online or real-time measurements. The measurements are taken only before and after the application of wear, since weighing of materials requires disassembly from the test setup. This method is used for brakes and tires in the scope of this research. Also, when using this technique for brake pads, mass change due to moistening should be taken into consideration, since brake pads are porous composite materials. Touch probe method is employed with a coordinate measuring machine. The principle of this technique is such that when probe of the machine touches a point on the measured component, it deflects with respect to the arm of the machine and coordinate of that point is recorded. With this measurement tool, thickness of the wearing element is measured at certain points. The average of the differences in thickness and base area are utilized to determine volume loss of the element. Laser scanning is similar to touch probe in the sense that it is performed with a CMM. The laser head of the machine sends light beam onto the surface of interest, and the reflections from the surface gives information about the distance between the sensor of the machine and the point on the surface. So, dimensions of an object can be acquired and volume change due to wear can be determined. This method is utilized for brake parts in the scope of this research. Now, let's move on to the light scattering method. While some particles that leave a wearing surface stay on car components, the others may become airborne. The detection of these particles is realized with light scattering technique. This method uses the principle of diffraction of light, or it can be named as deviation, when it hits a particle. In this application, a detector at known angles measures the intensity of light after it is diffracted. The key point here is that size of the particle affects the change of intensity of light respect to angle of diffraction. For example, when a small particle is placed here, light intensity is more uniform at these different angles, while a larger particle causes a larger variation of light intensity at different angles. Therefore, particle size and concentration information can be obtained with this method. This method also makes continuous measurement possible. In image processing method, 3D images of a varying surface are recorded with an interference microscope. Processing of these images yields 2D surface profiles, and the profiles before and after the wear are meshed. Matching is required because slight shifts and rotations may occur between the compared images. The reason is that pin-on-disk or ball-and-disk setups, which I mentioned previously, are used in these tests, and rotating components may not be stopped at the exact same positions for comparison. So compared images are repositioned relative to each other, considering the general shape of the profiles. After matching, the difference of the profiles is used for determining the amount of wear. This brings us to a modern, state-of-the-art technique which utilizes radioactivity to measure wear rate of machine parts, namely radionuclide technique or RNT. This method is used on the actual product without any model test setup, and continuous real-time measurements are obtained while the machine part is working. Hence, these make radionuclide technique an accurate, time, and cost-effective method. Moreover, since the part is wanted to be examined is radioactivated selectively, wear test of a particular component in an assembly of machine parts can be done without any ambiguity. This technique is applied in two ways: concentration flow and thin layer difference. When a flow, such as lubrication, is established and wear particles are carried through it, concentration flow is preferred, whose schematic is provided. In concentration flow method, the particles leaving the surface are detected, whereas in thin layer difference, the amount of particles remaining on the surface is measured with the placement of the detector near the surface of interest. The first step of the procedure for both sub-methods is activating the material whose wear rate is analyzed. The surface of the desired component is activated by bombarding it with a beam of ions. Although the use of neutrons in the early states was posing a risk for surroundings, which required shielding from the surroundings, use of particles such as protons, deuterons, and alpha particles eliminated that risk and allowed tests without shielding or protection. When the material is activated, the unstable nuclei of it starts emitting radiation in the form of alpha, beta, gamma, and X-rays, which can be detected with the sodium iodide scintillation detector. Also, a housing made of lead is employed as a radioactive insulator around the measurement zone to prevent interference of natural radioactive emission from the surroundings. With the data obtained, wear rate is determined using the change in radioactivity. In conclusion, I have discussed the setups and techniques for the wear measurement of some car components. Principles, procedures, advantages, and disadvantages regarding the techniques are required in this study. The research during this study indicated that the methods measuring wear rates continuously and on the actual component are superior in the accuracy, cost, labor, and time effectiveness. So I think further focus should be on the development of methods employing real-time measurements and using the actual components. Thank you.